Hello everybody and welcome to Embedded TV Live, and in this episode I'm going to be going over the 8 things that I made a list of that are important, I think, to pay extra attention to when designing boards with a STM32 microcontroller. So we're going to be going over a few very good tips on debug connectors and a few other things. But let's get started. So tip number 1 that I usually implement on my boards is a special dedicated UART for having a console on the chip, and this is very useful when you're when you just need to see the trace of the program, maybe print out some values, and you can't often do that through standard means through which the product is communicating with the outside world. So having an extra UART specifically for the debug messages is very useful to just see what is going on. For example, I have a board right now where I'm putting together my device tree for this board, and this is the output of the console. And I actually have commands in the console. I can see the processes that are running and any information that's related to the system that's running on the chip, and this is extremely useful. So I always put a dedicated UART on the circuit board, and also UART works as an extra way to flash firmware in case no other way works, and you just have to use the built-in bootloader and flash the firmware over UART. So you can always do that. For example, if you don't have any more ST-Link V2s available or don't have a JTAG adapter. Now, when it comes to JTAG connectors, one of the latest things that I started using is one of these. So this is a special connector called Tag Connect. You can look it up on Mouser or DigiKey. Actually, I bought this one from DigiKey. I think it's only DigiKey that's selling these. And they fit straight into the PCB, and they have springy pins. So you basically just press it in like this on the PCB, and you can program the firmware on the microcontroller. One of the things about these connectors is that they are actually designed for automatic flashing of the firmware. So if you're thinking that you want to flash the firmware automatically to the microcontrollers during manufacture, then one of these connectors is very, very good, because this can be mounted on a machine that just places it in place and just puts it in and flashes the firmware. And the pins, the larger pins here, they keep the connector in place where you're flashing. So very useful piece of equipment. And the footprint is very small as well. There are 2 versions. There's one with 10 pins and one with 3 pins. Next tip that I always forget is leading out the SVO pin to a connector where I can actually monitor it. The SVO pin is a special output to which you can output debug information from the ARM core. So this is hardware accelerated. It has actually a first in, first out queue where you can push bytes, and you can even do that from interrupts outside of the main UART. So let's say typically you would have a console running on, like, using a standard driver where you're using interrupts, maybe you're using DMA, but if you're going to be printing out from an interrupt, things get a little bit tricky. Now you have to think about doing a special case when printing out from an interrupt. And the SVO pin is specifically designed for the purpose of tracing the execution of the program. So it's designed to be very fast, and it's hardware accelerated in more than one ways. So for example, you can configure the hardware to automatically output the program counter to the SVO pin at regular intervals. And by doing so, you will eventually get a very good picture of the tracing of the execution, so that you basically get code coverage. But because you cannot output every single clock cycle, it just samples the program counter at regular intervals and automatically outputs it to the SVO pin. So having this pin is very useful when you need to trace or when you need to use the built-in debug hardware that is included into all STM32 chips. there's actually a special dedicated ARM debugger, and it's not mentioned in the main datasheet, but you have to go into the ARM datasheet for the ARM architecture and look it up there. And you will see all the registers and all the configuration options in this big, the really big datasheet that is concerned with the ARM architecture itself. One of the other things is that if you want to do any kind of longer delays, like longer than 1 second, then it's very useful to have the RTC Crystal mounted. It's very unreliable to use the main clock crystal. While it can be pretty close to the 8 megahertz or whatever frequency you're using, I typically use 8 megahertz, but it's still gonna drift, and it's gonna drift depending also on the capacitors you use, and it's like you can never be 100% sure. So if you have to have delays that are longer than 1 second, you really should be using the RTC Crystal, because it's designed for the specific purpose of keeping track of time. So it's very exact, and the RTC clock is designed to keep track of time. So if you use the RTC clock to keep track of longer delays, you will get very precise time delays, and they will be reliable every single time. I remember once we had a board where we needed to track motion for multiple several seconds. The motion was. The motion plan was to be executed over several seconds, and when we didn't have the RTC clock, we had problems with precision, because the main clock wasn't precise enough to give the precise timing for the motion profile. So having one of these is very useful, and they're not very expensive either. They're very small. They just fit right by the chip. Another thing is about communication. So if you want to communicate with anything, if you want to connect multiple boards together, or let's say you want to have some kind of control board where you have connect buttons to it, and then you maybe have several other boards that control different actuators, CAN bus is probably like the perfect solution for that, because it's simple. It's not like obviously you could use Ethernet or EtherCAT or any other or RS422 or whatever, but CAN bus is really probably the simplest solution to having a 2-wire network connecting multiple nodes together. So whenever I need to communicate with any other peripherals over wire, I just use CAN bus, because it's completely superior to anything else that's out there. Unless you need very high speeds, in which case CAN bus is not very fast, but it's still 1 megabit per second. So, and if you use CANFD, but of course that will be an external chip. STM32s don't currently have CANFD, at least not the F3, F4, F1 chips that I typically use on my boards. So, next thing, like this is really obvious. I mean, having a debug LED is probably something that everybody puts on the board, but it's like when you don't have the debug LED, that's when you really understand that it's quite a useful little piece of like a little component on the board, because when you don't have anything connected to the board and you just need to make sure that the board is alive, then the debug LED, just having it blink in a task, in a background task, just blinking the LED means the system is running. So if any communication is not working, then it's probably something else and not the system itself not running. Just putting it on the board, you don't have to like mount it, but just putting a footprint there so that you can have it there when you do development, it's extremely useful and probably underrated. When it comes to expansion, there is a very good it's not a standard, but it's just a layout of the connector, and it's called UX connector, and Olimex is using this connector for all of their expansion boards, and it includes an SPI interface, a UART interface, and an I2C interface, if you can multiplex the UART and the I2C functionality on the same wires. So it's very useful for any kind of expansion. If you want to have an expansion port, it's better to use a connector that's already been used before, so that it's compatible with with the open hardware boards that are available that use UX connector. So whenever you need to do SPI UART I2C for external expansion, just put all the pins, wire them up to the UX connector, and it's gonna be compatible with any future stuff that you'll be doing. Just to have some kind of standard. And last but not least, the USB port. So the higher end STM32 microcontrollers, the F4 chips and above the F4 series, they have a USB bootloader. So you don't actually need any extra cables or any extra serial adapters or JTAG adapters if you want to flash a new firmware to the device. Not even mentioning the obvious, that the USB allows you to have very reliable high-speed communication with the computer. The flashing functionality is often overlooked, and it's very practical to have a USB port where you plug in your cable and flash, and use the DFU util to flash a new firmware. And when you do layout of the USB cables, just make sure you don't put them close to any other components, because I had the issues where I placed the USB cable close to UART cable, and they were just interfering together, and I wasn't able to communicate over the serial port while the USB was running. So since they're high-speed signaling cables, they should be just placed away from other components and have shielding around them. So that's it. This is a very basic set of tips that good to have on any STM32 board. I hope you learned something, and thank you for watching. Subscribe below, and see you later.